Alrighty, 3.5 overlapping triangles. Here are the notes. We have given angle 1 is right, angle 4 is right. We also have given that angle 2 is congruent to angle 3. And we want to prove that AB is congruent to DC. Okay, now in this case, we are going to use the overlapping triangles. We want this triangle right here, ABC, and the triangle on the right side, which should be DCB. Okay, so I'm going to draw them separately over to the right. If you'd like to look to see what triangles we need congruent, you can do that right now. So over here are our two triangles, ABC and DBC. We want to try to prove, again, that AB is congruent to DC. In order to do that, we need to prove the triangles congruent first. So go ahead and write down these two givens. If we know that two angles are right angles, we can say that the two angles will be congruent. So angle 1 is congruent to angle 4 because all right angles are congruent. Okay, if you want this whole entire angle, look to see angle 1 makes up part of the angle, and so does angle 2. So if I add them together, I get angle ABC, which is a whole angle of the triangle. So let's go ahead and do that. We're going to write down angle 2 is congruent to angle 3 underneath. And if I add 1 and 2 together, I end up with angle ABC congruent to angle 4 plus angle 3, which is angle DCB. Okay, this will be my first angle for either side angle side or angle side angle. Okay, so I've used my givens so far. Let's look for another side. Notice that BC is going to be the same in both triangles. The triangles are overlapping here, so we are going to use BC as a side. So BC is congruent to BC, and that is reflexive. There's my side. And the last one, well, I do have angle 3. Remember angle 3 was here, this corner. So this corner will always be also congruent to the other one in the corner here too, which would be here. So I can say that as well, and that is a given. It's already written here, but I can just rewrite it. So that way I have an angle side angle. Okay, once I have the three congruency statements, angle, a side, and angle, I'm going to group them. Now say the triangles are congruent. Triangle ABC, congruent to triangle DCB. And now AB is congruent to DC. And that ends my proof. Let's go back and put our reasons down. Purple reasons. 1, 2, 3, 4, 5. Okay, so my first reason, I have two right angles are congruent. So I'm not going to say definition of right angle. I'm going to say step 1, all right angles congruent. Number 2, we are adding 1 and 2 together to get ABC, so this is addition. Reason 3, how do I know something's equal to itself? That is because of reflexive property. Number 4, how to get the triangles congruent in the first place? We have angle side angle. And step 5 is CPC, TC. All right, now example 2, we have AB congruent to AD. We have angle 1 congruent to angle 3, and we want to prove angle E congruent to angle C. So the triangles are going to be ADE and ABC. Okay, now there is something overlapping in these two triangles. Looks like angle 2. If I add them to 1 and 3, then they'll get this entire angle, angle A, and I'm sorry, angle EAD and angle CAB. So let's go ahead and start with our givens. We can go ahead and start with our side first. We have AB congruent to AD. Okay, that is in fact a side of the triangle. Okay, we also have a C congruent to AE. It's a little wobbly. AC congruent to AE. So that's also a side. Okay, and I am given an angle here. Angle 1 congruent to angle 3. However, angle 1 is not going to be part of the entire triangle that I need. I need angle 1 and angle 2 combined. So because angle 2 is reflexive, remember the same thing equals itself. I can say angle 2 is congruent to angle 2. And if I were to add these two together, I get angle BAC congruent to angle DAE. Okay, so we have a side, and here is going to be our angle in between. All right, so if now I can group these, I have side, angle, side. I can now say triangle BAC is congruent to DAC. Triangle DAE, I'm sorry. So we can now say angle E is congruent to angle C. Okay, going back to do our steps, we have 1, 2, 3, and 4. Okay, because 1 is an angle equal to itself, we are going to say reflexive. 2, how did I get from small angles to a large one? Well, I added them together. That is addition. Number 3, I'm going to go with side, angle, side. That's how I prove the triangle is congruent. And 4 is CPCTC. And that ends our proof. Okay, example 3 is a little bit trickier. I want to prove AD congruent to BE. So if you want to try this one on your own, go ahead and do so now. What I have is angle 1 congruent to angle 2, so these little angles congruent, and I have AC congruent to BC, so the entire segment. Okay, what I'm going to do here is actually prove these triangles congruent. So ACE, and the one on the right would be this one, BD, CBD. Okay, now once these two triangles are congruent, I can subtract their two pieces here. So this little piece and this little piece, and I'm left with the two remaining ones. Okay, there's no other way I can prove it because if I have this angle here, the vertical angles, that would be angle, angle, side, and that's not an angle that would be part of the triangles. Okay, so that would not work out. So go ahead and do angle 1's congruent to angle 2. That's ugly. Let's do blue. Angle 1's congruent to angle 2. Okay, I have AC congruent to BC. Those are both my givens. And if I'm doing this triangle here, CAE, and this triangle here, CBD, this angle is going to be reflexive. It's part of both triangles. The triangles are overlapping, and it is in fact part of both triangles, like I just said. So angle C is congruent to angle C. I have enough information now to prove that triangle ACE is congruent to triangle BCD. Okay, now parts of those triangles, ACE, again it's here, and this one here, BCD, are going to be these two little pieces, CD and CE. So from the triangles congruent, I can now say CD is congruent to CE. Okay, if I subtract, I have a big piece, AD. If I take away the little piece, big piece, BC, take away the little piece, CE, I am left with the AD and the BE. So after this step, this is why this one's a little bit trickier. you have to realize that you can pull something from the triangles, and then afterwards we're going to have to subtract. So we can't just have one statement for subtraction, we need two. What are we subtracting? Here we have a little piece. The big piece, remember, is my AC, congruent to the BC, which was given in the beginning. So once I had the two pieces, I had the big piece AC, the little piece CD. I can subtract the two. I'm left with AD and BE. Okay, so in this case, CPC-TC did not end my proof. I did one extra step to figure out that I'm going to have to subtract once I get the two pieces. So my reasons for this one is reflexive. Angles can be reflexive when they overlap. Step two, we have an angle, side, angle. If you need to write that down, go ahead. Next to it, angle, side, angle. Step three is CPCTC. And the last one, how did we go from a bigger piece to a littler one? It is subtraction. And that ends my proof.